So we're going to prove the formula. It's called the difference formula for cosine. I'm going to go back in time a little bit. If we had 2 points, x, y, do you remember the distance formula for the distance between 2 points? Do you remember that? Yeah, that's the change in x plus the change in y. But what did we do with each of those? Why did we do that? It is the Pythagorean theorem. Here's x1, y1. Here's x2, y2. And so when we found the change in x, that was this side. Found the change in y, that's this side. So if we take the square of each of those, some square root, you'd get the distance. So that's where that comes from. I want to use that today. The other thing I want to remember is that cosine theta is the same as what on an xy coordinate system? X. And what's sine? Y. And then what is cosine squared plus sine squared equal to? 1. So write those down real quick. All right, so here's what we're going to do. We're going to take some distances. The first distance is going to be on the arc length. We're going to just go all the way to a point A here. And A is the length, like 2 pi over 3. What's the coordinate if the distance on here is 2 pi over 3? What's the coordinate for it? What's the x part? Cosine of arc length A. So write that down. What will the y part be? Sine of arc length A. So that's my coordinate for this distance on here. And I'm going to erase it. It's like theta, yep. The arc length on the circle theta, yep. Then when we get to this other one, B, you're going to go from here all the way up to B. And when we do that, B is my length, distance on the circle. So what will the coordinate for this one be? Cosine of B, comma, sine of B. Yep. So that'll give you that one. Now imagine that I took a there we go. I went from here to here. All right? And that's the distance that I wanted to go. We'll call it distance 1. And then I'm going to slide this thing on the circle. Oops. Get back here. I need to clone it first. And I'm going to slide this on the circle. And so it's the same length all the time. A little hard to do simultaneously. It'd be great if I could, but you know, it's moving down so it gets to about here. Let's say that that's the same distance. If this were a distance 5 and this were a distance 4, I need to make this just for visual purposes. I need to make them just a little bit more different. So it's confusing. There, that looks a little bit better. All right, and let's say this whole distance to A is 5, this distance to B is 3. What would the distance to the end of this rod be? What would that distance be? 2, right? A minus B. So would you write that A minus B? What would the coordinate be of the arc length A minus B? A minus B is the length like 2. It's the length A minus B. What will the coordinate be? Cosine of A minus B, comma, sine of A minus B. Fantastic. And this will be my distance 2. I'll give you a chance to write that. So now that I know this, I'm going to say distance 1 should be what to distance 2? They should be equal, because that's what I'm stating. Good. So to do that, I'm going to take some values here. I'm going to take this one first. x1, y1. This one, x2, y2. And I'm going to find the distance from point B to point A. And that distance is just going to be the change in the x, which is cosine B minus cosine A. And what do we do with those two, the difference of those? Square them, yep. Plus, then what will the next part be? Change in y. Sine of B minus the sine of A squared. And that'll be that distance. How hard will it be to find the distance from, and I'm going to use my highlighter here a little bit. I took these two to find distance 1. I'm going to take these two here to find distance 2. So what will this one be? Put this down here. What will this square root be? Well, it's going to be the change in x. Let's go x2, y2, and x1, y1. So we'll go cosine of a minus b minus what? Change in x. So this minus 1. Is that all right? And then what will the second one be? The sine of a minus b subtract what? 0. Fun. I'm going to square both sides, if you don't mind. If I square both sides, I don't need to worry about these square roots anymore, do it. So that's that. Now, I'm going to do the fun part. I'm going to cosine b minus cosine a. Oh, shoot. How did that happen? I reversed those. I didn't want to do that. Won't matter. Cosine a times cosine b minus cosine a. We're going to FOIL this out. Okay? So the cosine b's will be squared. Cosine squared b. And how many of these cosine a times cosine b's am I going to have? 2 of them, and they'll be negative 2, right? And then we'll have a cosine a squared, and that's going to be plus or minus, negative times a negative. Plus, yep. Likewise, I'm going to have this one expanded, sine squared beta minus 2 sine a times sine of b, because it'll just be the FOILing of that, plus sine squared a. So now I've expanded that. Go back to red. I'm going to expand this one. Cosine squared a minus b minus 2 cosine a minus b. Minus 1 times minus 1 is plus 1. This would be so great if I could get this to fit on this line. What is sine a minus b minus 0? Sine squared a minus b. You don't have to, but if you want to, you can clap for me. This is the first time I've ever gotten that to fit on one line. Nice. All right. So once we get it here, I want you to look at this and tell me what is the next step. There's something big that's going to happen that can make this so much simpler to deal with. I'm going to highlight something here. Actually, I'm not going to. I'm going to take this cosine squared b. What could I map it with that would be really awesome? Why is that? That's equal to 1. That's a really weird looking one. Okay, and then how about this cosine Cosine squared A, what can I map that with? Sine squared A, and what will that be equal to? 1. Okay. And are there any other of those we can do? Where? Excellent, Tommy. So you've got it. That's your next one. There you go. So with that, we can simplify this quite a bit. This is going to be 1 plus 2 cosine A cosine B plus 1 minus 2 sine A sine B equal to 1 minus 2 cosine A minus B plus 1. Once you have this, is there anything that I can cancel out? Anything nice to cancel on both sides of the equation? A 1. Just 1? There's another one we can do. So then what we'll be left with will be negative 2 cosine A times cosine B minus 2 sine A times sine B equal negative 2 times cosine A minus B. And now what can we do? Divide everything by negative 2. And let's see, negative, so that'll be positive, and that'll be equal. And what we just did is we took the cosine of the difference of those. Let me take that back here. Okay. We found the difference of two things. For example, let's say I took the cosine of pi over 2 minus pi over 2. Did I do plus before for my example? So what's the cosine of pi over 2 times the cosine of pi over 2 plus the sine of pi over 2 times the sine of pi over 2? And this should be... And then I did a... Oh, I didn't do a minus before. I did a... Yeah, this needs to be a minus because that's what we just did. Okay, so, well, let's figure this out. What's the cosine of pi over 2? 0. What's the sine of pi over 2? 1. So what is 0 plus 1? 1. What's the cosine of pi over 2 minus pi over 2, or the cosine of 0? 1. So this works out. If you travel to the southern part of the world, you're going to come to a lot of Spanish-speaking countries. And in Spanish-speaking countries, they're going to use the cosine A minus B a lot. You know how they memorize them? They're very clever down there. The cosine A minus B is remembered as coco, C. And it's the cosine of the first times the cosine of the second plus the sine of the first times the sine of the second. And you just proved one of the toughest trigonometric formulas. We will prove about 10 more when you get back, but congratulations. So this 0 should be a 1. So it's 0 plus 1, which is going to give you 1. Yep.